Sometimes when we're trying to prove that particular components or particular triangles are congruent, we can't get exactly there just with the information that we have. Sometimes we have to use other congruent triangles to find corresponding parts to then use to prove that the triangles that we want are congruent. And this is something that I have often called a multi-stage proof. Basically, what that means is that we are using more than one set of congruent triangles, because sometimes we can't prove those two congruent triangles that we want immediately. Instead, there are other triangles that we can prove congruent, and then we can use those corresponding parts to get at the triangles we want. So, for example, if we have this quadrilateral below, quadrilateral ABCD, where you know that BD and AC are diagonals, if we know that BD bisects ABC and ADC, we can prove that AE is congruent to EC. But because of the nature of this particular quadrilateral and setup, we can't get there right away. There is no way to prove, using just the information that we have, that any of the triangles that are going to tell us that AE and EC are congruent parts are congruent right away. Instead, we need to use another set of triangles that we happen to be able to prove are congruent in order to get some corresponding parts that we can then use to show that the smaller triangles that contain AE and EC as corresponding parts are congruent. So there are a few different ways of doing this. What we're going to see in this video is one of those ways. So let's make them a little bit smaller here, and let's get started. Statement. Reason. Relatively small, just in case we need to add another column. So, as we have said all along, we need to make sure that we are showing that these pieces are congruent so that we can use the congruence postulates. Angle 3 is congruent to angle 4, angle 1 is congruent to angle 2 because those are given. Now we have two angles, so all we need is a side that is congruent to show that two triangles are congruent. Well, even though we can see these intersecting lines in the center of the quadrilateral, if we ignore line AC, line BD runs between congruent angles 1 and 2 and congruent angles 3 and 4. So what we can say is that BD is congruent to BD because of the reflexive property. Now, what we know from that, we know that in triangle BAD, we have two angles, 1 and 4, and the included side, BD, that are congruent to two angles, 2 and 3, and the included side, BD, of triangle BCD. So this large triangle here, and this large triangle here in purple. Those are the triangles we can immediately show are congruent by angle side angle. So, triangle BAD congruent to triangle BCD by angle side angle. Now, what does that do? That doesn't get us exactly where we want to go. It doesn't tell us anything about the corresponding pieces of AE and EC because AE and EC aren't edges of those triangles. But it tells us about some corresponding parts of those triangles. We can choose either of the two remaining corresponding sides to give us information that we want, depending on what triangles we're interested in. In this case, I'm going to choose BA and BC. They are corresponding parts of two congruent triangles. So segment BA is congruent to segment BC because CP-CTC. Great. Well, now that we have that, we have more information about the small triangles that we're actually interested in, BAE and BCE. But we only know that because we proved the larger triangles BAD and BCD congruent first. We already know that angle 1 and angle 2 are congruent. Those are in both of those triangles. We don't have to say it again. Once we say it in a proof, that's it. We already know that BA and BC are congruent because they are corresponding pieces of larger congruent triangles. And now we have that same sort of shared side here with BE. We know that BE is congruent to BE because it is itself, so that's the reflexive property. And now we have enough information to say that the two smaller triangles are congruent. So we know that triangle BAE is congruent to triangle BCE, now not because of angle side angle, but because of side angle side. Now that we have those two triangles congruent, well, now AE and EC are the corresponding pieces that we wanted to know in the first place. So AE is congruent to EC, all because of CPCTC. Now, we chose in this proof triangles BAE and BCE to use as our smaller triangles after we proved that BAD and BCD were congruent. That step was important, showing that the larger triangles were congruent, because that gave us CPCTC, which gave us that information. We could also have chosen to look at triangles DAE and triangle DCE for the corresponding pieces AD and CD from BAD and BCD also. Either set of triangles that we chose, we were going to be able to get to AE congruent to EC. And that's the idea of a multi-stage proof. Not everything we do is going to go right at the components that we're looking for. Just knowing that angle 1 and angle 2 were congruent and angle 3 and angle 4 are congruent, we didn't have enough information just with that to prove that AE was congruent to EC. But by using the larger triangles BAD and BCD, finding their corresponding congruent parts, we could then create smaller, different congruent triangles that got us at the pieces that we were interested in the first place. And that's the whole idea behind a multi-stage, multi-triangle proof.